Physics Part 221. For oscillations to be simple harmonic, the spring must obey Hooke's law throughout this extension and must not exceed the limit of proportionality. Furthermore, for large amplitude oscillations, the spring may become slack. Ideally, the spring would have no mass, but if the suspended mass is more than about 20 times, I beg your pardon, please. But if the suspended mass is more than about the 20 times mass of the spring, the error involved in assuming that the spring has no mass is less than 1%. The example of simple harmonic motion is particularly useful in modeling the vibrations of molecules. A molecule containing two atoms oscillates as if the atoms were connected by a tiny spring. The spring constant of this spring depends upon the type of bonding between the atoms. The frequency of the oscillation of the molecule can be measured experimentally using spectroscopy, and this gives direct information about the bonding. This model can be extended to solids, where atoms are often thought of as being connected to their neighbors by springs. Again, this leads to an experimental way of obtaining information about the interatomic forces in the solid. The simple pendulum. The figure illustrates a simple pendulum. Ideally, a simple pendulum is a point mass m on a light, inelastic string. In real experiments, we use a pendulum bob of finite size. When the bob is pulled aside through an angle theta and then released, there will be restoring force acting in the direction of the equilibrium position. Because the simple pendulum moves in the arc of a circle, the displacement will be an angular displacement, theta, rather than linear displacement, x, we have been using so far. The two forces on the bob are its weight, mg, and the tension, T, in the string equal to the tension in the string. The component of weight at right angles to the direction of the string, mg sine theta, is the restoring force F. This makes the bob accelerate towards the equilibrium position. The restoring force depends on sine theta. As theta increases, the restoring force is not proportional to the displacement in the case of theta. And so the motion is oscillatory but not simple harmonic. However, the situation is different if the angle theta is kept small, less than about 5 degrees. For these small angles, theta is proportional to the sine theta. In fact, if theta is measured in radians, then theta in radians is equal to sine theta. You can check this using your calculator. Some values of the theta over rad and sine theta are given in the table. This means that for small amplitude oscillations of the angles of the STR1, vertical should be less than about 5 degrees. The pendulum both oscillates with simple harmonic motion. A full treatment of the theory shows the period of T is related to the length of L of the pendulum. L is the distance between center of mass of the pendulum and bob. The point of suspension is C figure by the expression.